Jai Hind to everyone. Myself is Gaurav Srivastava, Assistant Professor in Electrical and Electronics Engineering Department in Ajay Kumar Garg Engineering College, affiliated to Dr. APJ Abdul Kalam Technical University, Ghaziabad, so to Lucknow. So today we have discussed about wind energy, and this topic is related to the subject renewable energy resources, subject code KOE074. This subject is run by the university in a final year, so student can opt as a optional subject, or you can say the optional subject open elective, in which the student can learn different type of energy sources which are available for us, like non conventional. So basically we have discussed previously, you can say the energy development in India and the abroad. Mostly we can develop the energy from the conventional sources like coal, gases, oil. So these are the basic resources which can be utilized for the energy production, but these sources are limited availability. So we can move the energy generation from non-renewable to the renewable, or you can say the non-conventional to the non-conventional energy resources. So today about wind energy we have discussed. So like what is the wind energy, their wind power, how it is measured, or you can say the different sources, applications, then different site selection we are find out ki like content we have discussed about wind power, site selection, and the criteria for the site selection is again important for any energy, you can say the plant development. If you have seen that if you are going for the hydropower plant, so definitely you find the best location and the river water availability continuously. So similarly in terms of the wind energy generation, we find out the best location, what is the site selection criteria, so that we can maximum utilize of the wind available and we can produce the energy accordingly. Then principle behind the wind energy production momentum theory we can discuss. Different type of classification of the rotors, like whatever the rotors we have using in the windmills. So simply we can define as the classification rotors as a windmills. Then concentration and arguments which are used as a mechanical part, which are for the production, for the establishment of the wind power plant. Then wind characteristics, time to time performance, and the limitation of energy conversion system. So these topics will be covered today in a wind energy. So like here in this picture you can see what is the wind, how it is generation. So basically we have located the different mills on a location where this wind turbines can be rotated, these blades, and through these blades you can see the energy, kinetic energy will be produced, and this kinetic energy will be using as a gone for the alternator for the conversion mechanical to electrical, and then you can say the alternator like they can produce the energy. So wind power is usually generated by the wind turbines situated either onshore or the offshore locations, in which we can say the kinetic energy of the wind is measured as a cubic proportional to its velocity. And is being used for the centuries in a water pumping, windmills, irrigation fields, and the navigation. So this energy is not a new generation of the energy resources. So these are the centuries of time, you can say this wind energy we can utilize for the different applications, like small water pumping situation, or you can say the windmills, irrigation fields, you can do it. So wind energy is utilized by means of the windmills, and many projects on the windmill system for water pumping and the production of small amount of electrical power being taken up in our country as well. So wind power energy, so availability we can discuss about where what is the current capacity of India or abroad, or whatever the different sites locations are available. So like wind power generation capacity in India has significantly increased in the recently years. We can say that in 2021 the total installed wind power capacity was 38.789 gigawatt, and this is the fourth largest installed wind power capacity in the world. So after the coal, gases, nuclear, then we can say the fourth largest you can the install wind power capacity in the world, approximate 38.7989 gigawatt. So wind power capacity is mainly spread across the southern, western and the northern regions due to large availability of the winds. So that's why these reasons are the mainly we can the power capacity utilization. Power cost in India are decreasing rapidly, definitely कि जैसे जैसे आप यूटिलाइज करोगे विंड पावर स्टैब्लिशमेंट को तो इनिशियली कॉस्ट जो होगी तो डेफिनेटली आपकी रिड्यूस होती जाएगी. The realized tariffs of water action a record low of the 2.43 per kilowatt hour without any direct or indirect subsidies during auction of the wind project in December 2007. So आपका प्रोडक्शन जो आपकी इलेक्ट्रिसिटी कॉस्ट आती है डेफिनेटली कि हाँ आपको 3-5 rupees per unit, 7 rupees per unit, but in terms of the wind energy we can record low as a 2.43 rupees per unit. So however the levelized tariff increased 2.77 per kilowatt in the March 2021. So like government announced the applicable guidelines for the tariff based wind power auctions to bring major clarity. So like that is a wind power capacity generation in India 2007. Like in the 2006-7 we can say the total capacity is around 7,850 megawatt. But due to you can see that year by year their production will be increasing. कि टारगेट आपका 32 था इंस्टॉल कर लेकिन जनरेशन हम 46,000 किलोवाट मेगावाट एनर्जी जो है आपकी जनरेशन आपकी यूटिलाइज हो रही है. सिमिलरली इन द 17, 18, 18, 19, 19, 20, 21, 21 जनरेशन 59 गीगावाट्स और इंस्टॉल कैपेसिटी आपकी इतनी थी. तो इंस्टॉल्ड कैपेसिटी एज वेल एज द जनरेशन टोटल पावर and that is the state wise ki how we can divide it, because in India we have different states and their availability of the wind and the generation of the wind energy we can classify it as ki like Tamil Nadu 9,000 approximate and Kerala you can say the 62.5. So this is the state wise energy generation of the wind. That is a different size कि like कि हाँ हमने state wise production देख लिया energy generation का. So that is the important windmills or you can say development we can situated in India. Kazri windmill at the Jodhpur, Rajasthan. Water pumping windmill by the Bangalore, again Bangalore, Gujarat, Bangalore, Tamil Nadu, in Rajasthan. So this is the name of the windmills which are situated and the developed by the government. Wind turbines. What is the wind turbines? So basically wind turbines like windmills होती हैं are mounted on a tower to capture the most energy, क्योंकि आप जितनी हाइट पे जाएंगे उतनी ही आपकी वेलोसिटी इंक्रीजेज हो रही है. तो आपकी विंड मिल्स जो थे तो आपकी जितनी हाई पे ब्लेड्स रहेंगे देन यू कैन से द फाइंड आउट द एक्सट्रीम वेलोसिटी, देन यू कैन convert or you can find out the kinetic energy of the wind turbines because of K proportional to V cube. तो वेलोसिटी हाई होनी चाहिए. Approximate 100 feet 30 meters or more above the ground they can take advantage of the faster and less turbulent in the winds. Turbines catch the wind's energy with their propeller like blades. Usually 2 or 3 blades are mounted on a shaft to form a rotor. 3 shaft, 2 shaft, 4 shaft, अलग अलग shaft के accordingly रहता है. तो जितना ज्यादा ये आपके रोटेट करेंगे देन आपकी एनर्जी प्रोड्यूस होगी काइनेटिक एनर्जी रोटेशन के थ्रू एंड दिस एनर्जी कैन बी कन्वर्टेड टू द इलेक्ट्रिकल. सो अ ब्लेड एक्ट्स मच लाइक एन एयरप्लेन विंग्स व्हेन द विंड ब्लोज अ पॉकेट ऑफ लो प्रेशर एयर फॉर्म्स ऑन द डाउनविंड साइड ऑफ द blades. Then again we have discussed about what is the more wind turbines. The low air pressure or the air pockets then pulls the blade towards the causing of the rotor to run. So this is called the lift. So the force of the lift is actually much stronger than the wind's force against the front side of the blade, which is called the drag. So there is a lift and drag positions are situated, and the combination of lift and drag causes the rotor to spin like a propeller, continuous motions, and the turning shaft spins a generator to make the electricity. Clear? And these wind turbines can be used as a standalone application, or they can be connected to a utility power grid or even combined with a photovoltaic solar cell. So there is a utilization ki haan, how much you can utilize these facilities. For utility scale sources of wind energy, a large number of wind turbines are usually built close together to form a wind plant, and several electrical providers use the wind plants to power supply to either their customers. So standalone wind plants turbines, you can say these are typically used for the water pumping, or you can say the communication purpose. However, you can say the homeowners, farmers and the anchors in the windly areas also use the wind turbines as a way to cut their electricity bills. A small wind also have potential as distributed energy resources, you can say the turbine. So distributed energy resources, you can say that refers to a variety of small modular power generation technologies that can be combined to improve the operation of the electricity delivery system. So these are wind turbines ki how it can be operated, and the power production we can be generated ki आप इसके थ्रू यूज कर सकते हैं कि आपका प्रोपेलर कॉम्बिनेशन आपका ड्रैग एंड ड्रैग लिफ्ट एंड ड्रैग कॉजेस की वजह से आपका रोटर जो होता है वर्क एज ए स्पिन लाइक अ प्रोपेलर, एंड देन टर्निंग शाफ्ट स्पिन्स अ जनरेटर टू मेक द इलेक्ट्रिसिटी. Then classifications. So classification of wind turbines. So wind turbines may be classified into the two categories. First one, horizontal axis, and the second one is a vertical. So like horizontal axis, we can mount here, that is the height of the tower in which you can find out the boxes. So there is a rotor blade, there is a gear boxes for the generator production, and that is the rotor diameter ki haan. But in the case of the vertical axis, what we do, we have find out the gearbox is shifted to their ground. Like vertical axis में आपका in the ground we can developing the gearbox, generator, and this is your shaft, or you can say the tower, and that is your blade, and the total diameter of the blade like length. So like this they can be rotated as length, and what horizontal you can say like आपके blades हैं इस तरीके से मूव कर रहे हैं और ये आपका ऐसे मूव कर रहा है. Then after the horizontal and the vertical axis turbines, we can further divide it, classified as the horizontal axis wind turbines like this. The orientation of these turbines are kept along the horizontal axis and can be divided into a monoblade, that's mean a single blade you can utilize, twin blade, three blades, multi-blade machine. So these are multiple options which are available for the energy production, or you can say the for the horizontal axis wind turbines. You can use as a single, double, triple, or multi-blade options. So what we can do in the single blade or the monoblade machines? So these are the very simples like this. Construction, installation, definitely installation is very easy and having low cost and the easy maintenance, because आपके पास एक ही है, सिंगल ब्लेड्स आप मेंटेन कर रहे हो तो उसी से आप एनर्जी प्रोड्यूस कर रहे हो तो उसकी कॉस्ट भी लो हो जाएगी, मेंटेनेंस भी लो रहेगी. कैन प्रोड्यूस ऑफ द लो पावर, तो डेफिनेटली जहां पर एडवांटेज है वी हैव एडवांटेज, सो पर्टिकुलरली वी हैव द लिमिटेशन आल्सो कि लाइक दे कैन बी यूटिलाइज और द प्रोडक्शन ऑफ ओनली 50 kilowatt to the 15 to the 50 kilowatt, and these are generally used for the pumping station, battery charging and the other agricultural purpose. You can say the small industries or small home appliances based application, we can utilizing the monoblade machines. But in the case of twin blade machines, what will happen? So here we can connected the two blades, and these machines are rated 1 megawatt to the 3 megawatt. They are less costly than 3 blades machine, but having large vibrations during their running. So this vibration is called due to unequal force at the lower end and the vertical position of the rotor. 3 blade machines, so generally we can utilizing the 3 blades, but they are high in the cost but also more efficient. कि like कि यहाँ पर आप देख सकते हो कि यहाँ पर आपका लॉसेस हो रहा है, वाइब्रेशन आपका बहुत ज्यादा हो रहा है, तो अनइक्वल फोर्सेस आपका जनरेट हो रहा था. बट इन द केस ऑफ द 3 blade machines, so they have the more efficient. So these machines are rated from low capacity 15 kilowatt to the higher capacity of the 3 megawatt. तो यहाँ पे आप देख सकते हो कि like 15 to kilowatt to 50 kilowatt. सेकेंड आपका 1 मेगावाट, थ्री मेगावाट तक जा रहा है, एंड इन द केस ऑफ दिस 15 किलोवाट टू 3 megawatt. एंड इन द केस ऑफ मल्टी ब्लेड मशीन्स हैविंग कि आपके लाइक 1 2 3 थे या मल्टीपल है कि 4 5 6 एनी नंबर्स ऑफ यू कैन टेक, कि आपका रिम्स है, रिम्स के अकॉर्डिंगली आपने इसको कनेक्ट कर रखा है. हैविंग हाई स्टार्टिंग टॉर्क कैरेक्टरिस्टिक, दिस मशीन आर यूज फॉर द पंपिंग ऑफ वाटर ओनली. ओके, so that is the classification of horizontal axis wind turbines. Now we have moved to the classification of the vertical axis wind turbines. So these turbines are mounted on the ground level and their blades go from top to bottom. What we have seen in the horizontal, like in a horizontal we can mount it on a top. We can say the pillar or you can say the tower. At the tower top we can mount the blades, and these blades at the generator and the gearbox can be mounted on the top side. But in the case of the vertical axis wind turbines, what will happen? These turbines are mounted on the ground level at wind, like this. ये आपका है, सो यहीं पर आपकी विंड मिल सिचुएटेड हो गई और यही आपकी रोटेट कर रही है. तो यहां पर आपको थोड़ी सी विंड कम मिलेगी, बट इन द केस ऑफ हॉरिजॉन्टल व्हाट विल हैपन कि यहां पर आपका सर्कुलेशन हो रहा है, तो यहां पर आपकी विंड ज्यादा मिलेगी, क्योंकि विंड हाइट पर आपकी ज्यादा है तो वहां पर ज्यादा हो जाएगी. सो दे आर क्लासिफिकेशन ऑफ टू डिजाइन, दैट इज फर्स्ट कॉल्ड Savinius type and Darius type. So these two types of classification is available in the basis on their designing. So that is a Savinius type rotor and that is a Darius type. कि आपका ऐसे रोटेट हो रहा है और ये इस तरीके से आपका कि लाइक दिस. क्लियर? तो ये आपका ऐसे रोटेट करता रहेगा, एंड ये आपका क्लोज है एंड दैट इज अ ओपन. फर्दर वी कैन सी हियर in such turbine what will happen? S shaped rotor, also called S rotor. Savinius S type, Darius D type. तो ये आपका क्लियरली S shape आ रहा है. Is supported at the top and bottom of two circular pits, and in the case of the D type, the turbine consists of a number of curved airflow blades mounted on a vertical rotating shaft or a framework. Covered किया हुआ पूरा. The hollow cylinder is sliced into a two pieces and each of these halves fixed to a vertical axis with a fixed gap. The air strikes on concave side circulating through the center. and the tip of the speed ratio of the turbines 1:2, efficiency about 15 to 30%, and rotors having low, you can say, the 100 rpm, and these are basically useful for the agriculture purpose, not for electrical generation. Like we can't utilize this energy for the energy production or the large capacity utilization. So basically this application is fixed like in the agricultural field. But in the case of the Darius type, what will happen? Darius rotor is spinning and the forward through the air in circular path. These turbines are available in size of the 5 megawatt to 14 megawatts. So definitely we have the large capacity, and efficiency also increases approximate 35 to 40. So these are the for the energy generation purpose we can utilize. Again, we have discussed different parameters which are used for the wind energy site selection. Ki how we can select the site, ki where we can install the windmills. So there is a particular some parameters, like first, that is a major important, that is the wind speed. Second, locations. So like when locating a wind turbines takes into the site account site average wind speed minimum we have to find out 11 to 13 miles per hour. You can say the 6 meter per second, which are available for the better energy production for the through the windmills. So it is a very high high range of the wind requirement. So that's why wind speed is a major important factor for the installation, or you can do the site selection. What will happen? A small differences in the wind take the big differences. क्योंकि जितना ही लो रहेगा उतना ही आपका प्रोडक्शन लो रहेगा, एफिशिएंसी लो रहेगी. बट अगर आपके पास हाई स्पीड है तो डेफिनेटली आप एनर्जी प्रोड्यूस में जा सकते हो. कि like a small difference in the wind is makes a big difference in the electricity produced by the wind turbine is a cube. क्योंकि आपको पता ही है कि आप kinetic energy what is the proportion, that is the velocity of. तो wind velocity का अगर जितना ही आपकी wind लो रहेगी, what will happen, kinetic energy आपकी डेफिनेटली आपकी डाउन हो जाएगी 3 times. So like an example, all the things being equal, a site with 16 miles per hour wind speed of 14 will generate a 50% more electricity. Location feature. Second, again important parameter for the site. On-shore system, the highest point is often the one of the with this point. So there is another element that should be considered and several constraints. Valley, mountains, forests, to simply large sets of trees and fences may have a big impact of the wind directions and the speed on their best location. So we have to find out the locations where we can establish कि like कि आपने ऑन शोर लेके चल रहे हो कि ऑफ शोर आपने अपार्टमेंट के बीच में स्टैब्लिश कर रखा है तो डेफिनेटली आपको विंड उतनी सर्कुलेटेड नहीं मिल पाएगी. एंड अगेन आपके पास ऐसी सिचुएशन है जहां पर माउंटेन्स हैं, फॉरेस्ट हैं, तो वहां पे भी क्या है आपको कंटिन्यूसली विंड नहीं मिल रही है, ब्लॉकेज मिल रहा है क्योंकि लार्ज सेट ऑफ ट्रीज अवेलेबल हैं, तो आपकी स्पीड मेजर करेगी. तो डेफिनेटली हमको ऐसी साइट को अवॉइड करना चाहिए. Trees, building and other obstacles, you should site turbines not only in the high wind area but also for the enough for buildings, tree tops, fences for the good clearing and put the wind turbines on a sufficiently tall tower. Then third is location and prevailing winds. Wind direction may vary significantly, but there are prevailing directions that you should study. Like in which direction you can mount the windmills, opposite or the same phase or the vertical, you know. So the turbine should face the prevailing winds and they should get the turbine without any obstacles. Local requirement. Take into the account local requirements. What is the, because the planning of the wind system location, assessment, environmental assessment होना चाहिए, studies on the impact on vary. communications, local air traffic for instance. So वाइल्ड लाइफ, क्या आपने वहाँ पर इस्टेब्लिश किया कि वहाँ पर एनिमल्स और वहाँ के वाइल्ड एनिमल लाइफ को कुछ प्रॉब्लम क्रिएट हो रही हो, तो डेफिनेटली वी हैव टू डिस्कस एंड फाइंड आउट द बेस्ट sites availability so no can be harm and easily available. Environmental issues. In the case of large of the medium wind turbines and the system, and environmental impact assessment involving potential noise or the wildlife impact. Potential noises. क्यों? Why? Because of the windmills. कि हाँ जब windmills rotate करेंगे तो definitely they can produce a large noise, and these noise can be not good for the health for the humans as well as the animals. So we have to find out the best location where they can't impact on the social life of animals as well as the humans. Wind turbines location and SSX. Often between the major objects to the development of wind system and the questions that we should not be minimized when studying their location. To get high wind speed, turbines have often to be located in the very high visible places with possible negative aesthetic impacts. ट्रांसमिशन इंफ्रास्ट्रक्चर, क्योंकि ऐसा भी ना हो कि आप ऐसी साइट सिलेक्शन करो कि जहां पर आपको इंफ्रास्ट्रक्चर को ट्रांसमिट करने में प्रॉब्लम हो रही हो, वहां पर ट्रांसमिशन हाई वोल्टेज ट्रांसमिशन लाइन ना आ रही हो, so that definitely we can avoid it, this type of location. When selecting a site, the existence and the proximity of high voltage lines is an important advantage. So running a power line from the utility grid to a remote site location involves high cost $50,000 to more than $50,000 per mile depending on the type of ground. Offshore and the wind system locations. The offshore location of wind farms may allow some important advantages over the onshore locations, like availability of large areas, particularly suitable for the many major projects, higher wind speeds, wind speed often increasing with the distance from the shores, less turbulence, and the inexistence of the obstacles like buildings or the mountains, and consequently you can say the more favorable wind patterns and the less negative wind loads like turbines, lower windmills along shorter, relatively shorter towers. So now wind energy and its resources. So basically we know that there is an indirect form of the solar energy. They are caused by the uneven heating of the earth's surface and its rotation. So definitely that is the indirect source of the solar energy. The winds can be classified into the two categories, that is the first one local winds and second one is the latitude wind. So what is the local wind? So local wind is caused due to the unequal heating and the cooling of ground surface and the water bodies of at day and the night. But in the case of planetary wind, we can say these are the cause due to the unequal heating of the earth's surface near the equator and the northern or the southern poles. So here we can say the unequal heating and cooling, but this is the unequal heating of the earth surface near the equator and the northern pole or either the water bodies at day and night. So during the in the local winds, we can say that during the daytime land is hotter than the sea, due to which here the surface becomes hot faster than the sea, which creates a pressure difference between the surface and the shore. Due to this difference, pressure cool at high temperature zone, and these are known as the sea breeze. So because of this, air from tropical region flows upward and moves towards the poles, and cool air from poles moves towards the tropical region. So these two types of energy we can available. and then we find out the expression ki how we can calculate the wind power. Like this, if we suggest the m is the mass of the air moving with velocity v per unit time, then what will happen? The power associated may be calculated as power is equal to half mv square, and if A is the cross sectional area of the wind streams and rho, that is the density of air, then what will happen? The mass flow rate can be of the air we can be calculated as this, m is equal to rho AV. So rho is the density of air, A is the area, cross sectional area, and V is the velocity. Then you can calculate the power associated with the half rho AV mv square. Here you can put this m value to this equation. What will happen? Half rho AV v square. So again this become half rho v a cube v cube. So that's why we have calling the kinetic energy proportional to the v cube. What will happen? The diameter of the wind arrow turbines we defined as the d. So area we can define it as the pi by 4 d square. So again the total wind power we can define as P is equal to half rho pi by 4 d square v cube. So this equation becomes 1 by 8 P pi rho d square v cube. So again we can find out different cases. The power transfer by wind turbines, the amount of power transferred wind is directly proportional to the density of air, wind speed, and the area of the opening is given in the equation 3. ये तो आपने किया था, rho d and v डायरेक्टली प्रोपोर्शनल आ गया आपका, P is rho v and area. ठीक है, ये आपका रो था, ये v क्यूब था, ये स्क्वायर था. Clear? So if a basic layout of the wind turbines shown in the figure having different parameters shown, what will happen? The thrust on the turbine momentum can be calculated. The power extracted by the turbine is the PT, and we know the change in kinetic energy into the extracted power. So what will happen? V rotor is equal to total V in plus V out divided by 2, and the net rate flow of the mass through the turbine is m rho V out total. We can find out the equation again, thrust on the turbine we can find out, F is equal to, that is the total thrust, pi by 8 rho d square V in square minus V out square. Similarly we can find out the power. So this is the mathematical expression ki how you can calculate the wind power. So now we have towards the end of this topic we can discuss about their merits as well as the demerits. So merits of the wind energy is like their abundance availability for the no price. So definitely whenever we had discussed about various conventional non-conventional energy resources, or you can say the renewable energy resources. So this is a major availability ki haan, they have the abundant availability for the no prices. So again fuel cost is low, no, nil. What will happen? Their maintenance cost, their running cost is also low. Useful at the remote places, also for the electricity generation, नॉन पॉल्यूटिंग एंड द इको फ्रेंडली. डेफिनेटली कि यहाँ रिन्यूएबल है तो आपका नॉन पॉल्यूशन की आप थर्मल में कन्वर्ट नहीं कर रहे हो, कोल को बर्न नहीं कर रहे हो, गैसेज नहीं जनरेट कर रहे हो. सो डेफिनेटली दे आर द इको फ्रेंडली. They can be utilized for the end user also, ki like ki where we have requirement to produce utilize this energy at the same location and the site selection we can do it. Ki like if you want agriculture field, so the same site where we can't utilize this energy, we can set up this plant. Suitable for power supply at the offshore and the onshore locations definitely, and the cheaper installation cost and the almost negligible recurring expenses. So definitely आपका installation cost and the negligible recurring cost can be compared to the thermal plant with the same power capacity. Same capacity if you measure, what will happen through the thermal power plant, the installation cost also cheaper and almost negligible recurring or the running costs. Demerits. So whenever we have discussed about the advantages, so they have the limitations also, like they have a less favorable in the city's location as the wind is available at the higher location definitely. It is unreliable and independent, it is not available the regularly. So definitely sometimes we have to require this energy to the continuous availability, but sometimes the wind is not approximately available, or you can say the as per the requirement velocity, wind velocity we have not produced, so energy generation is tough. So these are unreliable, we can't continue supply, as well as they have the noise pollution also, so we can't establish in a city locations as well. Flow of wind is not guaranteed throughout the year, so therefore its uses for the continuous supply power situation is not feasible. Due to fluctuation nature of the wind blowing, the produced mechanical energy has to be stored by some means of the battery storage as well. So present day wind energy systems are sources immense the noise pollutions. So these are the some limitations, or you can say the demerits. Or the disadvantages. Environmental impact and their limitations. So wind turbines can safely within the range of 5 meter per second to 24 meter per second wind speed. Proper land is required for the installation of the wind turbines. Tall buildings, towers, extra. Fatal collisions of the birds caused by rotating turbine blades, continuous blades are rotating and the birds is going, so what will happen, there is some fatal collision can be happens. Free from the tall buildings, tower, extra. So this is the environmental impact and their limitations. So thank you. So that is all about the wind energy. So we have discussed more about another renewable energy sources in our next lecture. Thank you.